Hi, welcome to a new episode of Tanu Tech World. We have come today with a very unique device called a Pico-hydro generation system. So this light and fan system we have developed from this Pico-hydro turbine. You can see it's working very good, and here we'll show you how to make it. This is the schematic diagram. We'll take some tools. So we'll first take the generator. This is the Pico-hydro generator, and to our bench where we'll make the lighting and fan device with it. And this is a very exciting device, and this can be used in rural households as well as urban households which have water supply. And for this we need some equipment and tools, so we'll show you how to make it. And here you can see we are at our lab, and we will make this Pico-hydro turbine. And for that we have taken the generator, we have taken two 1 watt lights, we have taken a volt ampere meter, we have also taken one small fan. So this experiment or project is to demonstrate how the system works and how we can make load generation system or load catering system out of it. So you can see we have taken a very good box, normal box, you can find it in the market, and now we will cut out our acrylic sheet into the size of the cover of the box. So we have purchased this acrylic sheet, we have done the measurement, now we have cut it. We have to make some holes for fixing all our equipment over here. So normally we'll just check whether all our equipment, all the loads fit into this box. So this project can also serve as a lab equipment. All of you guys who are working in academic institutes, colleges, and so if you want to demonstrate Pico-hydro setup, or if you want it for your project work, you can make this, and this is a very nice setup to demonstrate how micro-hydro or Pico-hydro generation system works. So you know, Pico-hydro or micro-hydro is a renewable energy source. So if you have water flowing, then you can generate power from it. So here what we are doing is we had made some holes for the switches. We are now putting the switches in the lower section of the controller. So this box serves as both the controller and the load bank. So where we would put up the loads, we will put up the controlling system, we'll put up the control mechanism, that is the switches, and we'll connect it to the Pico-hydro generation system which is already available in the market. So we'll attach the components one by one to the box. We are attaching the fan right now. So later on you can either replace it with bigger loads if you have a bigger system, and this is a demonstration system. So the meter is a VI meter. You can measure the voltage and the ampere of your generation as well as what the load is consuming. You can measure it with this. We are fixing two 1 watt LED cob lights in here, and this will serve as the lighting load. Okay, so here we have fixed the lights using instant glue, and now you can see the controller looks ready. Just we have to install the power conversion system, and for our power conversion system we are using DC-DC converter, and for the voltage and current measurement system will be taking power from a 9 volt battery. And when the system is on, when the system is operational, then only we'll turn on the meter and we'll check for power. Otherwise the meter will be off. So we'll conserve power that way also. So here we are fixing and we are connecting all the connection wires to the respective switches for control, and this is the DC-DC converter that we will be calibrating right now. So here we have our multimeter. We'll set the input voltage, and according to the variation of input voltage, the output voltage will be constant. So this is the function of the DC-DC buck converter, that the input may be variable but the output will be constant. But we have to keep in mind the output voltage should be about 1.5 volts below whatever the minimum voltage we are getting from the generation source. Here you can see we have calibrated the buck converter to 4 volts. Now the rest of the connections will be made as per the schematic. So schematic will also be shared. There is a link for the where you can get the schematic, and it will also be displayed, so you can check out. You can pause the video and you can check out the schematic. So we'll make all the rest of the connections. So here you need to use a very good soldering iron and very good wires, so that the connection is not interrupted later on. So always while soldering, we always use high quality soldered and high quality high wattage iron for this soldering purpose, because these are large switches. Not large, but they are suitable for this scale of applications. They are not surface mount, so as they are not surface mount, they will require little bit more solder. And the connections are to be made very carefully, and please see the schematic diagram properly while making the connections, because any wrong connections will damage your entire device, entire unit. Because the micro-hydro generation system, this is a Pico-hydro one, because it generates about 5 watts at the peak, and our model we have reduced the generation to about 1 watts, but we can successfully run 2 1-watt lights with 100 milliwatt fan. So we are able to run this at low power. So of course, based on your water availability, you can design your load bank as per your Pico-hydro generation system. Normally you can get up to 10 watts of Pico-hydro turbines directly from the internet. You can buy, and then you can design your load bank as per your generation system. So here we are fixing all the meter, and the current probe and the voltage probe are to be soldered very carefully, because the current will be in series with the load and the voltage will be parallel to the loads. This has to be taken care of. Another thing is, when a DC-DC converter is working, it is wise to install a diode with DC-DC buck converter, so that any ripples or any transient components can be minimized. So you need not install a full bridge rectifier or a suitable high capacity rectifier, just a small diode, because this is a small power generation system. A small diode will do or will suffice. So here we have this meter which is powered by the small 9 volt battery. These batteries have very low capacity, so we will try and conserve power for this. And here you can see our meter is calibrated to about 4 volts. There is a drop also, and it's successfully able to run the loads. And you can see at peak power drawn is about 12 watts from this, because but our generation system is about only 1 watt. So this is where the experiment lies, so that we can really test if a 1 watt generation system can at all run a 12 watt load. So hopefully this will run, but all the loads will run at, of course, partial loading, or with low capacities, as the peak power we are pushing into the loads, or which is available to the load, is very less than what is rated. So this will be a very viable experiment, especially for rural areas where you see power is limited, and then you can have anything you want. So design has to be made very carefully, and after everything is tested, you need to install all the components in the box. We are using double-sided tape here to install the battery and the DC-DC converter. You can install it permanently also if you wish to develop a permanent setup for it. So here we have done a DC jack. We have connected it through DC jack so that several loads can be installed. Here we are installing our Pico-hydro turbine in our existing water supply system. So this water is coming from 300 liter tank installed at top of our building, which is 10 meters in height, and then we have connected it through our DC jack. We'll be temporarily installing it, so we are checking that the voltage and current VI meter works, and so we'll be installing it. Now we'll test this Pico-hydro turbine if it works. So we'll gradually turn on the water supply. We have to keep in mind that first, when we are turning on the Pico-hydro turbine, no load should be turned on. Load should be turned off. So the Pico-hydro turbine should be turned on at no load condition. Then gradually we are connecting the loads, switching on the loads, and then first at no load condition, then you will gradually switch on the loads. So then the turbine won't overspeed or get damaged, or pitting will not take place in the turbine. So we have these 3 loads, 2 lighting loads and 1 fan load. And you can see the generator is clearly overloaded, as the peak power, the rated capacity of the loads is 12 watts, and we are only considering active power because this is a DC power and this is a DC generation, so the reactive components we are not considering. You can see all the loads are working, but as the generator is overloaded, so the thing that occurs is you can turn one light, it will turn on, the voltage will drop drastically. As you can see, it will drop to 2.8, and it will not work at the rated voltage. Why? Because it will draw a very huge amount of current which the generator cannot supply. So it's drawing about 160 milliamps of current at 2.7 volts. So you can see the load which was earlier working at all the loads at 12 watts. So now you can see the loads, if you multiply 2.7 at 0.16, you will get about 0.4 watts. So So you can see the generator capacity has also reduced. So why is that? Because the generator is overloaded. We should not overload the generators. We should only run the loads which is lesser than the peak capacity of the generator. So peak capacity, if the peak capacity is 5 watts, then your load should be rated at 4 watts if it's a DC generation, because it's a Pico-hydro setup. And here you can see as the generator is overloaded, but we are still able to run our loads. So this system will be applicable, if designed properly, will be applicable for rural areas very effectively. Thank you.